Hello, and today's purpose of the day is I can apply translations and dilations to a quadratic function, day 2. Go ahead and take a look at the warm-up before we get started with our math video. Please check your answers with mine that I have listed, and we are going to review the transformation summary, so if that warm-up was difficult, we are going to, again, review a little bit of transformations with quadratics. So if you can recall, we have a vertical shift or translation up or down. If we see, for example, f of x plus c, and where c is a number, then we will go up c units. So whatever number is listed there, up that many units. If we have a number being subtracted to our function, we're going to go down that many units that we see listed. So we could either go translation up or a translation down. We can also have a reflection over the x-axis and y-axis. So here with this first example, if we have g of x equals negative f of x, and so our negative is, right out in front of our x squared term, we are going to have an x-axis reflection. If we see something like g of x equals f of negative x, that is a y-axis reflection. We have a stretch and compress if we have a number that is in front of our function that is either greater than 1, which would be a stretch, and I should say the absolute value of that number is greater than 1, it's a stretch. And if our number is, the absolute value of the number is between 0 and 1, then that's a compress. So again, stretch, think of that parabola as getting thinner, and compressed as that parabola getting wider. So again, it's all about the absolute value of that number that's in front of our x squared term. Then today we're going to talk specifically more about a horizontal shift. So up here at the top right, we could go left or right depending on some information that's in our function. So if we see f of x plus c, the quantity squared, this means we are going to do a translation of left c units. So if we see a plus a number in our parentheses being squared, that's really going to shift the parabola left. Also, if we see a number being subtracted from x in our parentheses being squared, that's going to shift our parabola right c units. So something to note there about the signs that we see. So again, a summary on transformations with quadratics. Now let's take a look at just a few examples incorporating all the transformations. So with our first example, and again, these are transformations from the parent function of f of x equals x squared. So let's take a look here, what we have. So I see a negative out in front of my function, so that's a reflection over the x-axis. Then here, I see x plus 5, the quantity squared. That means I am going to go to the left 5 units, or that parabola will shift to the left 5 units. And then here plus 3 means this parabola will be up 3 units, again, from the original parent function up here that's listed. All right, now with the second example, this 2 here represents a stretch, so this parabola will be a little bit thinner as opposed to the parent graph. I see x minus 3, the quantity squared, which means this will be right 3 units. And that is all the transformations that are occurring right there. Now let's take a look at the Desmos Graphing app. This is a great app to have on your iPad and can help graph any equation, especially quadratic equations. Let's take a look. Hello, and let's take a look at the Desmos Graphing app. This is a great app that can graph any type of equation, including quadratics. Let's take a look and make sure that our transformations from our notes are correct with the graphs that we'll be able to see using this app. So I'm going to first type in the parent function, which is f of x equals x squared. And so I can type in y equals, that's the same, or just different notation than f of x, means the same thing. So y equals x squared. So as you can see in black, that's the parent parabola. And then I'll type in our first example, which was g of x equals, which I'll type in y equals, negative the quantity x plus 5 squared plus 3. And again, this was from our notes. As you can see in red, that's the first example. That's the parabola that we can see with the transformations has reflected over the x-axis because it's opening downward as opposed to the parent graph, which opens upward. X plus 5, the quantity squared, again, we know that that means that that parabola will shift to the left 5 units, and you can see from the graph that it does. And then plus 3 means that parabola goes up 3 units from the original parent graph, which is just at 0, 0, the origin. All right, let's try our second example. Y equals 2 times the quantity x minus 3 squared. And again, in red, you can tell that that parabola has shifted to the right 3 units, and it is stretched. It's a bit thinner than the parent graph, which is, again, in black, and so you can tell that our transformations are correct. And so feel free to use this app and look at the different buttons that you can press and the different graphs that you can get. And again, this is a great app that will help with graphing any quadratic function or really any graph that we want to take a look at. Thanks for listening. Have a great day. Bye.